My name is Prabhar Ravichandran. I'm a research biologist working with Agriculture and Agri-Food Canada. In this video, we'll briefly go over the poster that we are presenting on multispectral imaging to estimate herbicide phytotoxicity in oat and mustard. Herbicide usage in agriculture has doubled in the past 3 decades, so the main reason for this is increasing number of herbicide-resistant weed species. Whether introducing a new herbicide or evaluating weed species resistance to existing herbicide, the assessment of their efficacy is very important. Canadian Weed Science Society has set protocols to assess phytotoxicity of these herbicides, which is predominantly through visual controlled ratings. Often these are labor-intensive and time-consuming. So we propose a method of using multispectral images and machine learning to come up with an effective model to estimate herbicide phytotoxicity. The objective here is to use the multispectral images to estimate herbicide phytotoxicity in 2 model species, one representing a grassy weed, that is tame oat, and the other is a broadleaf species which is modeled by oriental mustard. So the experiment was conducted in 3 locations, Lethbridge, Lacombe and Saskatoon. The randomized completely block design was used with 4 replicates, and we tested 6 herbicides on oat and 8 herbicides on mustard. So the multispectral images were collected before spraying, and following that we collected at 1, 3, 7, 10, 14 and 21 DATs. And after the images were acquired, we created orthomosaics with Pix4D mapper, and the shadow and soil features were removed using OSAV and manual thresholding. The plots were annotated with the RGB images that was extracted from the multispectral images, and following that we extracted the plot-wise data and we fitted partial least-square regression models. In addition to the visual control ratings, we also used a handheld device called GreenSeeker to get NDVI from the field. And here are our models. So we are in the first year of a 3-year project, so we are limited in data, so we tried to analyze both pixel wise and plot wise. In general, our plot wise data was performing better than that of the pixel-wise data. So this indicates that there is a heterogeneity in the plot, and the visual control ratings are provided on a plot basis, not on a pixel basis, as you may know. And the R-square varied between 40 to 75% for mustard and 65 to 75% for oat. So as we said, we are in the first year of study, and if we happen to have the data from year 2 and 3, we would have enough data to try some advanced deep learning models as well, which is in our radar. So I would like to thank the field crew for providing consistent support with our study at 3 different locations, and we would like to thank our funding partner, Western Grain Research Foundation. Thank you.